Assalamu alaikum. So after doing all the three transformations, reflection and translation and then stretch, let's start the past paper questions. So the first question that I have chosen here is from Summer Year 20 and it's variant 3 and question number 3. So the question says, in each part A, B and C, the graph shown with solid line has equation y equals fx, meaning this is the line, this is the graph for y equals fx, and the graph shown with broken lines here, this is the transformation of y equals f of x. So for part A, state in terms of f the equation of the graph shown with broken lines. So if we analyze the graph, what we see here is that this graph has been just reflected in the y-axis. This graph is just reflected in the y-axis. I can just count the units from the y-axis. It's 1 unit on the right side. On the left, again, it's 1 unit. 2 units here on the right, so 2 units on the left. 3 units on the right, so 3 units on the left. And it's the same graph which has been reflected. So I can say that it is basically the transformation such that I should say that this is the transformation so that it should be represented with respect to f of minus x here. So this is going to be the answer for part 1. Now moving to the second part. So moving to the second part, I can see that the graph here, state in terms of f the equation of the graph shown with broken lines. So what I observe here is that initially the original graph is this, from having coordinates 1 comma 2, 2 comma 1 and 3 comma 3. So with 1 comma 2, I can see that it has been transformed to 1 comma 4. Here it has been transformed to 2 comma 2, and the third point has been transformed to 3 comma 6. And all these transformations have been taken from, I can see that this has taken from 3 and 3. Over here initially it was 2 and 1, and here initially was 1 comma 2. So what I can see here is that originally all the 3 points, they were having the y coordinates as 2, 1 and 3, and after transformation they have become multiple of 2, so that the first one here is 2 2s are 4, here it's 2 1s are 2, and then here it's 2 3s are 6. So obviously that means that the stretch has taken place here, and it is the stretch in the vertical direction, along the y-axis in the vertical direction. So for such cases, I should simply say that the transformed equation should be y is equals to twice of f of x. So this is going to be the answer for the second part. Now for part C. For part C, what we can observe here is that the given function is here, the given function is here, and then the broken line lies here. So it's the same function which is getting translated towards the third quadrant. That means there is a translation along the x-axis, and then there is a vertical downward translation also. So if it is the horizontal translation along the negative x-axis, start counting the units. For the first point, it should be, for the first point, if I compare it with this negative 3 here, I can see that the first point should first be translated towards the negative x-axis. Therefore, it's 1, 2, 3, and 4. 4 units for this point, 1, 2, 3, 4. 4 units here, and then this point it should be 1, 2, 3, and then 4. So one thing is obvious, it is having a horizontal translation. It is having a horizontal translation of -4. And obviously there is a vertical translation also. And this vertical translation, just count the downwards unit. So if I do that, this point here, I've translated it by 4 units over here, so that this is my graph after the translation towards the negative x-axis by 4 units. Now just translate it downwards. This point 1, 2 and 3 downwards, 1, 2 and 3 downwards, 1, 2 and 3 downwards. So this means there is a vertical translation of -3 here. So if they have asked us to make the equation of the transformed vector, then I should say that this vector is y equals f, horizontal translation -4, so I should write it with +4 and then a -3. So this is going to be the answer for the respective transformation for part C here. The second question is from Winter Year 20, Variant 2, Paper 1, and the question says, function f and g and h are defined for x belonging to real numbers by f of x is 3 cos of 2x plus 2, g of x equals f of 2x plus 4, and h of x equals twice fx plus pi by 2. We can see that all the three functions here, they are having different types of transformations. So if I discuss the function fx, then what I see here is that the cosine function is getting transformed in three forms. Number one, I can see a +2, which is a constant. So this +2 shows a vertical translation in the positive y direction. So it's a +2 translation upwards. Then I have a 2x. This shows cosine of 2x. This shows that the function cos is getting stretched in the x direction by the scale factor 1 by 2. Third, I have this constant, the coefficient 3 outside the cos function. This coefficient shows that it is the stretch in the y direction or the stretch by the scale factor 3 in the y direction. If we look at the function gx, there are two types of transformations. Number one, +4, meaning the constant +4, it's getting translated positively in the y direction by 4 units. Then it's f of 2x, meaning function f is getting stretched in the x direction by scale factor 1 by 2. H of x, it's 2fx plus pi by 2. So x plus pi by 2, this shows a horizontal translation by -pi by 2. We know that the sign has to change. So it's a translation in the x direction by -pi by 2. And then we have this factor 2 outside the function, meaning that it is going to get stretched in the y direction by 2 units. So this is the understanding for the three functions that are given to us, f, g and h. So here it says, describe fully a sequence of transformations that maps the graph of y equals fx onto the graph of y equals gx. So fx onto gx, so fx is getting transformed to gx, so fx getting transformed to gx. We know f of x is 3 cos of 2x plus 2, getting transformed to gx, which is f of 2x plus 4. So here what I should know is that stretch, it's the stretch y scale factor, it's that we have the stretch of y by scale factor 1 by 2 in the x direction. It's the stretch It's the stretch by scale factor 1 by 2. Here it's a 1 by 2. It's a stretch scale factor 1 by 2 in the x direction here. So secondly, we can see that there is a vertical translation of 4 units, or it's parallel to the x-axis by positive 4 units, so that it's 0 and 4. So this is how we will be describing the transformation for the function fx to gx. Number 1, the function is going to get stretched by the scale factor 2 in the x direction, and secondly, there is a vertical translation by positive 4 units, therefore it can be given by the factor 0 and 4. So this is how I will be describing the sequence of transformations which maps f onto g here. The next part of the same question, it says describe fully a sequence of transformation that maps the graph y equals f of x onto y equals h of x. So f of x is getting mapped or transformed onto h of x. F of x is 3 cos of 2x plus 2, and h of x was twice of fx plus 2. So here what we can see is that we have a horizontal translation. What we can see here is that there is a horizontal translation by, obviously it's going to be a negative pi by 2. The sign in the horizontal direction, the translation in the horizontal direction changes by the opposite sign. Therefore, it's a horizontal translation by negative pi by 2, and therefore the vector for the horizontal translation is negative pi by 2 and is 0. And secondly, there is a stretch parallel, there is a stretch which is parallel to the y-axis, stretch that is parallel to the y-axis by the scale factor which is 2 units. So which is just a 2. So stretch parallel to the y-axis by scale factor 2 here. So this is how we will be describing the transformations. Let's do another question. This question is taken from year 20 and winter year 20, and it's variant 3, and the question says that the curve y equals x square is transformed to the curve with equation y equals x square plus 6x plus 5. So y equals x square is getting transformed to y equals x square plus 6x plus 5. So describe fully the transformations involved. So here they are asking about the transformations that are involved here. So for the transformations that are involved, what I can see is that the transformed vector is x square plus 6x plus 4. So if the transformed vector is x square plus 6x plus 4, then for that I should know that there has to be a quadratic equation or expression related to x square plus 6x plus 5. So to get that expression, I've just done some balancing by completing the square method. Divide 6, divide 6, the coefficient of x by 2. My answer is a 3. So I am balancing it with 3 square and negative 3 the whole square. This is quadratics by completing the square method. So there is a video also on quadratics completing the square method in the quadratics chapter. So you can refer to that if you want to also. So this is x square plus 6x plus 3. So this becomes x plus 3 the whole square, x plus 3 the whole square. Minus 3 the whole square will give you a minus 9, and minus 9 plus 5 will give you a negative 4. So with this translation, with this transformed equation, what I know is that this function has a horizontal as well as a vertical translation. So what is the horizontal translation? Obviously the sign changes, and it's a horizontal translation by a negative 3, and then there is a vertical translation by negative 4. So we can write that there is horizontal translation by -3 units, that is -3, 0, followed by vertical translation of -4 units. So therefore it's it's 0 and -4, and therefore we can say that the curve is getting translated by -3 and -4. So this is how I will be giving the translation vector for -3 and -4 for the given function y equals x squared 2, y equals x squared plus 6x plus 5. Let's do another question. So this question is from Summer 21, variant 2, and it says that the curve y equals sine 2x minus 5x, y equals sine 2x minus 5x is reflected in the y-axis and then stretched by scale factor 1 by 3. It's getting reflected in the y-axis. So, and there is a stretch by scale factor 1 by 3 in the x direction also. So, write down the equation of the transformed curve. So, to write down the equation of the transformed curve, what I know is that there is a reflection in the y-axis. So, if there is a reflection in the y-axis, then I know that it should be this 2x and x. This 2x and x, they should be getting multiplied by a negative sign because it's the reflection in the y-axis. Therefore, I have said that this is sine negative 2x minus 5 negative 5x. So, there is an identity related to sine of minus theta, and that identity is sine of minus theta equals minus sine theta. So, referring to this identity of sine of minus theta, which is equals to minus sine theta, I have said sine of minus 2x can also be written as negative sine 2x, and then negative 5 into negative x will be a plus 5x here. So that my final answer then is for the stretched, it's followed by the transformation, which is a stretched by scale factor 1 by 3 in the x direction also. So this means that the function 2x and x, they should be getting multiplied by a 3. So if they are getting multiplied by a 3, then I should say that it is minus sine 2 times 3x plus 5 times 3 times x. Therefore, the final answer is going to be y equals negative sine 6x plus 15x. So, this is going to be the final transformed equation for the curve. Moving to the next question. This question has been taken from winter 21, variant 2, and it's question number 2, which says that the graph of y equals fx is transformed to the graph of y equals f2 of x minus 3. Describe fully the two single transformations that have been combined to give the resulting transformation. So I can see that there are two transformations here. One is with respect to this 2x and the other is with respect to this negative 3. So here I can say that it's a stretch in the x direction, my scale factor 2 is within the function, therefore it's a stretch in the x direction, and it's by the scale factor, which is a 1 by 2. And then with this negative 3, I know that there is a translation in the y direction by negative 3 units, therefore represented by the translation vector, which is 0 and negative 3 here. So this is continued by the point 5,6 lies on the transformed curve f of 2x minus 3. So the same curve y equals f of 2x minus 3, for this curve here, for this function here, there is a point P which is 5, 6. So state the coordinates of the corresponding point on the original curve. So after transformation, there is a point which is 5 and 6. So what was the original point for this P, 5 and 6 here? So this is what the question is asking us for. So let's start working on it. We know that it is for point 5 and 6. So if on the sketch, if on the graph, I just sketch the point or locate the point 5 and 6, then this is where my 5 and 6 is going to be. So with this 5 and 6, what I know is that first it's getting this function P was obtained by a vertical translation of -3 units, meaning wherever it was initially, it has moved 3 units downwards. So that means if I go in the reverse order, then moving in the reverse order, I should say that the point 5 and 6, this has to be upwards by positive 3 units. So if I just add a 3 to this 6, add a 3 to this 6. So let's add a 3 to the 6 here. So 6 is the y coordinate. It's getting translated in the y direction. So I will be adding a 3 to 6, giving me a 9. Therefore, this is the new, this was originally the first y coordinate for P1. So here I can say that before the translation, the coordinate of P was 5, 9. Then we also said that there was a vertical there was a stretch in the x direction also, and the stretch factor was 2 units. Stretch factor was a 1/2 unit. In the x direction, the stretch is given as the reciprocal for the factor, whatever is given in the question. So we can say that the stretch factor here is a 1/2 unit, meaning if this is the position of the point P before the translation, then obviously it has squeezed by 1/2 for this x coordinate, which is a 5. That means initially this 5 was a multiple of 2. Therefore, I can say it's 2 times 5. It has to be 2 times 5, giving me a 10. Therefore, initially it was the point which was at 10, 9. So again, if I just go back to the translations that we have done, 9 translated downwards by 3 units. So 9 minus 3, that gives me a 6. So I have this x coordinate, the y coordinate, which is a 6. The stretch factor, by the stretch factor, this 10 has to be reduced by the scale factor 1/2. So 10 divided by 2 is a 5. Therefore, this is a 5 also. So this confirms that initially this point P was at P2, which is 10, 9. After transformation, it has transformed to 5, 6. Therefore, the original point of P 5, 6, the original location for P 5, 6 has to be 10, 9 here. So this is the solution for this question. So original point is 10, 9 here. So next question, and this is the question taken from summer 2022 variant 1, and the question says the curve y equals sine x is transformed to the curve y equals 4 sine 1/2x minus 30 degrees. There are 3 transformations that I can just observe here. So describe fully a sequence of transformation that have been combined, making clear the order in which the transformations are applied. So number 1, we can see that there is within the function there is a -30. This -30 shows that there has to be a horizontal translation by positive 30 degrees here. So horizontal translation by positive 30 degrees, therefore the vector represented is 30 degrees and a 0. Then we can see that there is a stretch parallel to the x-axis. Why is that so? Because I can see that with x I have a 1/2, therefore it has to be the stretch in the x direction by the scale factor, which is 2 units. thirdly, I can see that there is a 4 here outside the sine function. So that shows that it's a stretch parallel to the y-axis by scale factor 4. So this is going to be the order of this, or the sequence of transformations that have been applied to the function for y equals 4 sine 1 by 2x minus 30 degrees. So let's move to another question. This is question from summer 2022, variant paper 1, variant 3, and this is question number 4. And the question says that the curve y equals x square plus 2x minus 5 is translated by negative 1 and 3. Find the equation of the translated curve, giving your answer in the form ax square plus bx plus c. So the equation, that is the original equation that is given, is y equals x square plus 2x minus 5. So again, applying the method of completing the square, this 2 gets divided, this 2 gets divided by 2, giving me a 1. So I am balancing it by 1 the whole square and negative 1 the whole square. That gives me y equals x plus 1. X square plus 2x plus 1 can also be written as x plus 1 the whole square minus 6. So from here I can just give the translation, and I can say that it's getting translated by plus 1 given as a negative 1, the constant negative 6 that should be represented by a Alright, so this is the equation, which is y equals x plus 1 the whole square minus 6. Now the condition here says that it is translated by negative 1 and 3, that's given in the question. Therefore, negative 1 and 3 getting translated by these factors, I know that the function here for x, it should be, for changing the sign for negative 1, it should be for x plus 1. This was the original vector which I have represented by completing the square method. So if I need to translate it by negative 1 and 3, it means that here I should be adding a positive 1, because I know I have to change the sign. So adding a positive 1, and then with this negative 6, I should be adding a 3. So doing that, I am getting here x plus 1 the whole square minus 6 plus 3, that gives me x plus 2 the whole square and minus 3 here. So this is translated. Now the question has asked us to represent the transformed vector in the form ax square plus bx plus c. So the only thing that is left is to expand. So applying a plus b the whole square formula, this is a square plus 2ab plus b square, meaning x square, plus 2 into 2 into x, giving me 4x, and then 2 the whole square, giving me a 4, and then a minus 3. And then I can say that the transformed vector here is x square plus 4x plus 1. That is the given, that was the asked required form for y equals ax square plus bx plus c. So this is how the equation, the final transformed equation, is going to be. Part B of the question. So part B of the question says the curve with equation y equals x square plus 2x minus 5. The curve y equals x square plus 2x minus 5, that was the initial equation that we had. So this is transformed to the curve with equation y equals 4x square plus 4x minus 5. So describe fully the single transformation. So y equals x square plus 2x minus 5 transformed to 4x square plus 4x plus 5. So what I know here is, or what I can tell here is, that 4x the whole square can be represented as 2x the whole square. this 4x, if I just look at this function here, it's 2 times x, therefore I can just write it with x as 2 times 2x and a minus 5. So what I see here is that it's going to be fx, it's going to be the same function, which is 4x square plus 4x minus 5. So what I have seen here with respect to x is that the x function in both the terms, the x function is getting multiplied by 2. The x function, it's getting multiplied by 2. So when the x gets multiplied by a number, then what we know is that it has to be a stretch in the horizontal direction. And what is the scale factor? The scale factor has to be a reciprocal. Therefore, I can say that it's a stretch in the horizontal direction with a scale factor which is a 1 by 2. So that is going to be the solution here. So the graph with equation, now this question is from winter 2022 variant 2 and this is question number 5. So the graph with equation y equals fx is transformed to the graph with equation y equals gx by a stretch in the x direction with scale factor 0.5. So the scale factor is a 0.5. That means stretch in the x direction, scale factor is a 0.5 or a 1 by 2. Therefore, I know that whatever the function is has to get multiplied by x. For all the x values, they need to get multiplied by 2 here. So this is what it means when we say it's the stretch in the x direction. So it's a stretch in the x direction, scale factor 0.5, meaning whatever the function is, it has the x values need to get multiplied by 2, and we can say that the scale factor is a 1 by 2. So on in writing, in showing the expression, we will say it's f of 2x, but obviously all the x coordinates, they need to get divided by 2 here. And it's followed by a translation which is 0 and 1. So obviously we know that it's a vertical translation by 1 unit in the y direction. So the diagram shows the graph of y equals f of x. So this is the graph of y equals y of x. The graph in black is the graph of y equals f of x. So on the diagram, sketch the graph of y equals gx. So for making the graph, or for sketching the graph, what we know is that there is a stretch in the x direction by the scale factor which is a 1 by 2. Meaning all the x coordinates, the prominent x coordinates here are 0, then it's a 1, then we have a 2, then we have a 3, and then we have a 4. So all these x coordinates, they need to get divided by 2. So x values are 0. So obviously divided by 2, it will remain a 0. Then let's say we have another one, which is, we can see that the x coordinate here is a 1. So the transformed coordinate here should become a 1 by 2. Then the third x coordinate we have is a 2. So the transformed has to be 2 divided by 2, which will give us a 1. The fourth x coordinate is a 3, and the transformed x coordinate should be a 3 by 2, giving you a 1.5, and the final x coordinate that I can see here is a 4. So this should be transformed to 4 divided by 2, giving you a 2. So I can see that all these values, 0 remains a 0. This 1 here should get transformed to 1 by 2, meaning it should come here. This 2 here should get transformed to 1, meaning it should be coming here. This 3 should get transformed to 3 by 2, meaning 1.5, it should be here. And 4 divided by 2, so there is a stretch by 2 units, therefore it should be transformed over here. So after the stretch, this is going to be the curve, this is going to be the shape of the function fx that we should be having here. Second is the transformation, which is a translation of 0 and 1, meaning this curve needs to get translated in the y direction by 1 unit. So 1 unit translation, every point, every prominent point, just move it upwards by 1 unit. So 1 unit over here, initially it was at 1, so now it will be at 2. Then this point gets translated another 1 unit in the y direction. This point 1 unit in the y direction, this point 1 unit, this point again 1 unit, and then this is how I will be getting my translated curve by translation factor or vector, which is 0 and 1. So this is going to be my function gx. Now the second part of the question, find an expression for gx in terms of x. So what is going to be the function for gx? Obviously what I know is that it is having a stretch for f of x, therefore I'll be writing it as f of 2x, and then a translation in the y direction, therefore it's f of 2x plus 1. This is going to be my final transformed equation for the given function f of x. Next question is taken from Winter 22, paper 1, variant 3, and it's question 5 in the paper. So the diagram shows a curve which has a maximum point at 8 and 12 and a minimum point at 8, 0. The curve is the result of applying a combination of transformations to a circle. Initially we can see that this is not a circle, this is kind of an ellipse, but initially it was a circle. So for a circle, we know that for the circle there has to be the radius, which has to be having a constant value, and there has to be a center also. So initially this was not an ellipse, but it was a circle. That means that some transformations have been applied to the circle so that it has changed to the figure of an ellipse. So the first transformation applied is a translation of 7 and minus 3. And the second, it's a translation, meaning this figure had a translation in the x direction by 7 units and in the y direction by negative 3 units. And secondly, the second transformation is a stretch in the y direction also. So it has a stretch in the y direction. So state the scale factor of the stretch. Before starting to get our calculations, just observe that each unit on the grid is represented by 2, meaning if this is an 8, then the grid before is a 6, meaning the difference between 6 and 8 has to be a 2. So from here, what I know is that there is a stretch in the y direction. So obviously the x direction is not changing. So initially, if I can see that this is the center of the ellipse, if I can mark the center of the ellipse here, then this comes out to be the center. So what I can see here is that the distance along the x-axis, which hasn't changed because the stretch was only applied in the y direction. So the distance along the x-axis here has to be the radius of the circle. And what is the radius of the circle? I can see that the radius of the circle has to be a 2, meaning initially it was a circle, and this is how it should have been. If I just draw the figure, then initially without the stretch, this is how it should have been. This is how it should have been. But then because the stretch has been applied in the y direction, so if the stretch has been applied in the y direction, it means from here and from here it has been elongated or stretched by some scale values here. So this is the first asked question. State the scale factor of the stretch. To find the scale factor of the stretch, we know that there is a stretch in the y direction. So we have decided that the radius of the circle, it has to be a 2 unit, because there is a no change obviously in the radius. It's a stretch only in the y direction, so that means x direction, the radius has not changed. So if I just locate the center of the ellipse, then the center lies here, and from here in the x direction I can see that the radius is a 2 unit, meaning before applying the stretch, the radius was a 2 unit here, meaning this is how it should have been. This is how the circle would have been before applying the stretch. So what I know here is that the radius has to be or had to be a 2 in the beginning, which now has become which now has stretched in the y direction from 2 up till 6 units. From this point, which we are saying is the center of the ellipse, had to be the center of the circle before the transformation. Therefore, now it has elongated by 6 units. So, R2 has become 6 units. So, what is going to be the scale factor? Just divide the transformed distance from the center by the initial distance. So, that's a 6 divided by 2, and we can say that it's a scale factor 3. So, we can say here that the stretch factor in the y direction is equal to a 3 here. So, state the scale factor of the stretch. The stretch factor or the scale factor of the stretch in the y direction is equal to 3. Now, the second part of the question, it says the radius of the original circle. So, that we have already decided that the radius of the original circle in the x direction, there is no change, there is no stretch. Therefore, we have decided earlier also that the radius had to be 2 units. Now, the second part of the question states, state the coordinates of the center of the circle after the translation has been completed, but before. Now, these are the keywords that you should underline, and the keywords are, we need to have the coordinates of the center of the circle after the translation has been completed, but before the stretch is applied. So, before applying the stretch and after the translation has been completed, meaning whatever the original point was, now before the translation what it was. So, before the translation what it was, let's get the answer here. What we can say about this point, before the stretch, this point is having coordinates which are 8 and 6. So, before the stretch, we have decided that the scale factor was a 3 unit, and the y coordinate here is a 6 unit. Therefore, as we have applied the stretch factor, this 6 should get divided by 3, giving the answer of the y coordinate as 2. Meaning, I should say that before applying the stretch, this point here, the center of the circle should have been at 8, 2 here. So, this is going to be the center of the circle or the coordinates of the center of the circle before the stretch has been applied. I can say that my center is 8, 2. Now, the next part of the question, it says state the coordinates of the center of the original circle. So, what was the original circle? Original circle, obviously we know now that the center of the circle is 8, 2. Center of the circle is 8, 2. The translation, they have said that a translation has been applied of 7 and negative 3 has been applied. That means we should be taking it backwards. So, if I take it backwards, then obviously I will have a negative sign assigned to it. It's 8, 2, negative 7 and minus 3. That would give me 8 minus 7, which is a 1, and 2 plus 3, which gives me a 5. That means that initially it was the circle with the radius 2 at 1, 5. After the translation, this 1, 5, 1 plus 7, that gives me an 8. So, it has come to the x coordinate as 8, and then 5 with the translation of minus 3 in the y direction. 5 minus 3 was a 2. So, this is where it was initially if I just draw the circle here, so this would have been where it was initially after applying the translation. So after applying the translation, this is where the function or the circle was, and applying the stretch along the y direction. So it's 2 times 3. This point here, it has the y coordinate as 2. So 2 times 3 giving me a 6. It has elongated or stretched to 8, 6. This is a 4. 4 times 3, that gives me a 12. So it has elongated to a 12. And then obviously 0 would remain 0 because 3 times 0 would be a 0. So this is how the transformation has been applied to the circle, which was originally at 1, 5, translated by 7 minus 3, and then stretched in the y direction by scale factor 3 units. So this is all about stretch, reflection, and translation. I've tried to cover all the critical questions from the past papers in this video. I hope you like it, and I hope that the transformation topic is clear to everyone now. Thanks a lot, and in the next video we'll be starting the new chapter then. Thanks for watching.